Okay, we're going to draft the toolkit reciprocal function. Now, we've already seen in another video how to evaluate the values of the reciprocal function. The reciprocal function, of course, is y equals 1 over x. We use the standard x values. And of course, we already know that 0 is not going to work, but when we do this, we just go ahead and list them all so that we can clearly show the ones that we're not going to use. Okay, so if x equals -2, what's our calculation? Y equals 1 over x. So we're going to get 1 over -2, and that's pretty easy. That's just -1/2. So we don't really have to do a whole lot with this calculation. Very clear that we get -1/2. And at -1, we get 1 over -1. And of course, that's just -1. So we get -1 here. And then if we have x equals -1/2, we get 1 over -1/2, which is 1 divided by -1/2, which is 1 multiplied by -2 over 1. And of course, that's equal to -2. So we get -2 here. And when x equals 0, we get 1 over 0. And this is undefined. Another way of saying what we can say is it does not exist. DNE. If you're using open math, that's the way they usually want you to indicate an undefined quantity. It is undefined, it can't be defined, so we don't include it. And I'll write the DNE in here because some of the online stuff asks you to do that, okay? Okay, now if x is 1/2, we get 1 over 1/2. Of course, it takes 2 halves to make 1. But we can do that formally. 1 multiplied by, well, it's 1 divided by 1/2, which is 1 times 2 over 1, which is 2. Then we get 2. If x equals 1, we get 1 over 1, which is of course just 1. And if x equals 2, we get 1 over 2. Well, that's it. That's 1/2. Well, there are our values. So let's see what it takes to plot this value. And we'll start with the next axis. We'll take the interval from -2 to 2, divide that interval in half, and we're going to get 0. And of course, then we're going to have a y-axis going through x equals 0. And then we divide the interval from 0 to 2 in half, and we get 1. Divide the interval from 0 to 1 in half, and we get 1/2. Divide the interval from 0 to -2 in half, and we get -1. The interval from 0 to -1 in half, we get -1/2. And we can label these values, although some of them are going to get in our way. Okay, so we know what these values are. Now we need to label the y-axis. What are the values on the y-axis? Well, the values are as big as 2 and as well. Maximum value is 2, minimum value is -2. So we partition the interval on the y-axis from -2 to 2. So let's say, I'll do it here. This is -2. Halfway between 0 and -2 is -1. Halfway here is -1/2. Then up here we go in equal distance. We get 2. In other words, this distance and this distance should be equal. halfway here is 1, halfway here is 1/2. Okay. Now, we need to plot our points. One thing I'm gonna modify here, a -2 label right there is gonna get in the way. I'll just take a second. And label it just a little bit higher. Okay. Now, we have the point -2, -1/2. X is -2, Y is -1/2. So we sketch the line for X equals -2. And the line where Y equals 1/2. -1/2. And at the point where those lines intersect, well, X is equal to -2, Y is equal to -1/2. So that's the point, -2, -1/2. We can actually label that -2, -1/2. And a little arrow, and then we draw a boundary between the graph and the table. So there we have it. Okay, well, we can do the same for when X is -1 and Y is -1. So Y is -1 along this line. X is -1. Along this line. So the point where X is -1 and Y is -1 is here. We label that point -1, -1. Let's put something there. There. Okay, then X is -1/2 and Y is -2, so we sketch another line for Y equals -2 and a line for X equals -1/2. And we have a point here, and this point is the point -1/2. -2. Okay, so these 3 points are on the graph of the toolkit reciprocal function. We can do the same thing for the points 1/2, 2, 1, 1, and 2, 1/2. 1/2, 2, X is 1/2, so we draw a vertical line, the dotted line, X equals 1/2. Horizontal line for Y equals 2. And there's our point. And then 1, 1, well, Y equals 1. X equals 1. There's the point where Y was 1 and X equals 1. Then 2, 1/2. X is 2. Y is 1/2. So here we have a point 2, 1/2. Now we can label these points. 2, 1/2. And 1. And 1/2, 2. Okay, this is the graph of the basic toolkit reciprocal function. So the basic toolkit reciprocal function consists of a set of points. There are 6 points. That's it. That is the basic toolkit reciprocal function, the way I define it, the way I define it in my course. It's not a universal definition, but I think it's a useful. Sorry, I interrupted myself there. I had to write something down wrong. Okay. again, the way I break these functions down, I think is a good way to illustrate some things about domains and ranges. So I'm going to do that. Okay, so we have -2, -1/2, -1, -1, -1/2, -2. We don't have a point for x equals 0 because division by 0 is undefined. And then we have (1/2), 2, 1, 1, 2, 1/2. There's our basic toolkit reciprocal function, consisting of 6 points, no more. Now, to do the extended toolkit reciprocal function, going to indicate that with a blue curve. And the curve is going to start at this point. And it's going to go through these 3 points. And it's going to follow a smooth pattern through these 3 points. It's not going to go beyond this point. Now, the reason it doesn't go beyond, well, it's not going to continue past this point, but it will pick up again at this point. And we can get a nice smooth curve with a dot at each end point. We don't want to try to connect this point to this point. If we were to connect this point to this point, we would have to go through the y-axis. If we go through the y-axis, then at whatever point we cross, let's say we just try to connect it by a straight line. Okay, put a straight line here, it's going to go through the origin, 0, 0. That means that this function has a value when x equals 0, and that value is y equals 0. But it can't have a value at x equals 0 because you can't divide by 0. Okay, and that straight line also wouldn't fit the pattern of the pattern that you get as the x values approach 0. So we're not going to talk about that just yet, but it turns out you get a vertical asymptote, and we'll have to develop that idea when we develop a little more numbers. That's about small numbers. Excuse me. Okay, so this is it. Toolkit reciprocal function is the blue curve, the extended toolkit. So it's blue curve. -2, -1/2. To -1/2, -2. Okay, stops there. Then from 1/2 to 1/2. This curve and this curve, nothing else. That's it. Now there's complete toolkit reciprocal function. And what's going to happen to the complete function? You might know this. You're just going to continue getting closer and closer to the y-axis here. Getting steeper and steeper, but you're never going to get to the y-axis. It's going to go on forever, keep getting closer to the y-axis. Every time x becomes half as great, y is going to double. Okay, and that's going to get out of hand pretty quickly. Really steep. And similarly over here, every time x gets twice as close to 0, the value y is going to double. Okay, here's your value here. If it doubles, it's going to be down here. So this point will give you a point down here. This x value will give you a point down here, and so forth. you keep getting closer and closer to the y-axis, but you never get there because you can keep cutting your distance in half. You can keep getting twice as close to zero forever. Means you can keep doubling your y values forever. Well, if you double something forever, it gets pretty big really fast. And that's worth knowing. I'm talking about it now just briefly, so you have a little perspective. You don't necessarily need to understand what I've said after this, but it might be helpful if you think about it a little bit. Okay. And then if we go this way, every time x doubles, y is going to become half as great. So we double 2, we get 4, and the y value is going to be 1/4, and so forth. And we're going to approach the x-axis as an asymptote. Again, we can keep getting twice as far from the origin, from x equals 0. And cutting the y value in half, we keep doing that forever. And that's exactly what happens if you look at the complete extended, or the complete toolkit reciprocal function. Okay, that's it so far. I was hesitating to decide when I want to talk about domain and range at this point. I think I'll do that in a separate video. So there we have it.